Okay, so these are really just review questions from basically this entire last week and a half. So let's look at this. What is the force of friction between a block of ice that weighs 930 newtons and the ground if the static friction coefficient is 0.12? We can write that like this. We know that Fs, our force of friction, is equal to mu s times the normal force. It says that it weighs 930 newtons. Well, we know that weight is equal to Fn. So that's really convenient, which means the normal force is equal to 930 newtons. And it says right here that our coefficient of static friction is 0.12. So we can really just fill in the blanks here. Say Fs is equal to 0.12 times 930. Let's write that. 0.12 times 930, that's equal to 111.6 newtons. That's your answer. Moving on. What is the coefficient of static friction if it takes 34 newtons of force to move a box that weighs 67 newtons? Well, we can just do it like this. We say that our static friction, right, is always less than or equal to, and I meant to actually do that up here as well, less than or equal to, boom. It's always less than or equal to the mu s times the normal force. Weight is 67 newtons. Our weight is equal to our normal force, which you already said before, so that's equal to the normal force. So if we're looking for our mu s, and if it takes 34 newtons of force to move it, that means that that's the threshold. So that means that 34, and we'll just make this an equality now, is equal to mu s times Fn, which is 67. So now we can just divide that over and we get that mu s is equal to 34 divided by 67. And we get this answer right here, 34 divided by 67. 0.51. A box takes 350 newtons to start moving when the coefficient of static friction is 0.35. What is the weight of the box? Again, just using this equation right here. Right, and let's not worry about the inequality anymore at this point. So mu s Fn, we know that Fn is the same as the weight, so if we find our normal force, we can find our weight. So let's say 350 is equal to 0.35 times our normal force. If we do 350 divided by 0.35, we get 1,000. So we say that our Fn is equal to 1,000 newtons, which means our weight is equal to 1,000 newtons. Moving on. Clarice moves an 800-gram set of weights by applying a force of 1.2 newtons. What is the coefficient of friction? Good, so let's find the weight of this first. We're only given a mass, okay? We're only given 800 grams. We want to always use kilograms. We always have to use kilograms when doing these force problems. So to change this into kilograms, we say 800 grams times 1 kilogram over 1,000 grams is equal to 800 divided by 1,000, 0.8 kilograms. So I hope you guys know what this is. I'm basically saying for every 1,000 grams, there's 1 kilogram. And if we have 800 grams, we want to divide it by 1,000 grams to get how many kilograms we have. So you can always set it up like this. Always put how many grams you have times 1 over 1,000, and you will get the right answer every single time. All right, so we have 0.8 kilograms. That is the mass. Now, let's go ahead and find the weight. Our weight is equal to mg, so we're just going to multiply this mass by 9.8. Then we get that equal to 7.84. And since this is also weight, we can also say that our normal force is equal to this, 7.84 newtons. Clarissa moves an 800-gram set of weights by applying a force of 1.2 newtons. What is the coefficient of friction? By saying Clarissa moves it, that means that they just got it past that threshold. So we're going to say that Fs is equal to mu s times Fn. If 1.2 is the threshold, and the coefficient of friction is right there, times 7.84. So really, our coefficient of friction is equal to 1.2 divided by 7.84. And we say that that's equal to 0.15. All right, next question. A car has a coefficient of friction between the ground and its tires of 0.85. What is the mass of the car if it takes 9,620 newtons of force to make it slide along the ground? Okay. Again, this is our threshold. These are all dealing with the threshold values. It would say kinetic if it meant kinetic. Let's write this equation out. Fs is equal to mu s Fn. Let's solve for the normal force of this car. We say that 9,620 is equal to 0.85 times n. Our normal force is equal to 9620 divided by 0.85. 11317.65 newtons. So 11,317 newtons. What is the mass of the car? Well, we know that Fn is equal to W, which is equal to mg. So now we can say 11,317.65 is equal to mass times 9.8. To find our mass, we're going to divide this value by 9.8. We're going to say that our mass is equal to 1,154.86 kilograms. Last problem. A 5-kilogram block has a coefficient of friction 0.15 on a flat surface. What is its acceleration if you exert a force of 15 newtons sideways on it when it's at rest? Find the friction force list. Okay, I had to make some quick changes to that. Didn't realize that made it through my edits. All right. So this is a mu k, right? It's kinetic friction because it's being moved. So let's see here. We write this as mu k times Fn. What is its acceleration if you exert a force of 15 newtons sideways on it when it is at rest? All right, so first, excuse me. Sorry about that. Okay, so first, let's find our normal force. So we're going to say the weight is equal to mass times gravity, which is equal to 5 times 9.8. $49, and that's going to also equal our normal force. So 49 newtons. 49. We're going to find the kinetic friction force that this block is going to be feeling as we push it with 15 newtons. So let's say 0.15 times 49. And we find that this opposing force from the friction is going to equal 7.35 newtons. Okay, so now we have two different forces acting on this block. We have the force applied, which is 15 newtons, and we have the force resisting or opposing, which is 7.35 newtons. Make that more clearly a 5. To find the net force, we can set that equal to our force applied minus our force of friction, right? Because this is not helping the force applied, it's hurting the force applied. So we'll set that minus Fa minus Fk, and we'll say that it's 15 minus 7.35. And we get that our F net force is equal to 7.65. I'm going to underline that, but we're not done because we're actually looking for the acceleration. We're looking for the acceleration that this block is feeling or seeing, or that we can see this block is doing. So we have 7.65 net newtons of force. We're going to set that equal to ma, right? F net is also equal to ma. We just found our F net, which is equal to 7.65. So 7.65 is equal to the mass, which is 5 kilograms, times the acceleration. We can divide our mass over, and we get that acceleration is equal to 1.53 meters per second squared. So go back, check your work. Hopefully you were able to do this nice and easy.